intensity. What do you mean by magnetization and what do you mean by magnetic intensity? We don't have derivation for this, but we have formulas, and for remembering the formula, I think I should explain you the derivation. It's not a very lengthy derivation, but still, let's see. The next one is magnetization. The magnetization. Let's see that there is a non-magnetic material. This is one non-magnetic material. This is non-magnetic material. Okay, this is non-magnetic material. Inside the non-magnetic material is magnetic net magnetic moment will be zero. Why? Because here charges will be in random motion. When we keep this material into the external magnetic field, this will align in a particular direction. If we keep this thing into external magnetic field, into external magnetic field, magnetic, it will be in a regular direction. It will be in a regular direction when you keep this thing into external magnetic field. When you keep this into external magnetic field. Okay, so in the case of here, what will happen? Your non-magnet will get converted into magnet. Your non-magnet will get converted into magnet. When your non-magnet is converted into magnet, that process is known as magnetization. And the electrical magnetic field which you were using here for converting this non-magnet into magnet is known as magnetic intensity. Once more. See, the process in which non-magnet is converted into magnet is known as magnetization. Okay, and the external magnetic field which is used to convert non-magnetic material into magnetic material will be known as magnetic intensity. The process of converting non-magnetic material into magnet is called, the process in which non-magnet are converted into magnet are called magnetization, and the external magnetic field which is responsible for magnetization is called magnetic intensity. What will be the formula for this? For magnetization, the formula is net magnetic moment to volume of material. This is the formula. Net magnetic moment to volume of material. Net magnetic moment to volume of material. This is the formula. We don't have derivation for this. You'll just have to remember the formula. It is the ratio of net magnetic dipole moment to volume of material. Now, what about the unit? if we speak about the unit, what is volume? Volume will be in terms of ampere meter square, and mnet, that is I into a current into area, we studied in the initial topic. It was am I audible now? I think there are some technical glitches. Okay, yes. So yes, the formula is net magnetic dipole moment to volume of material. Formula is net magnetic dipole moment to volume of material. What is net magnetic dipole moment? Yes. What about the unit? Unit will be ampere meter square. And what about the volume? Volume will be meter cube. So this cube and square will get cancelled and you will get ampere meter. Ampere means, meter means L1. Ampere means A1. Sorry, it's ampere per meter. So it's L minus 1 and A raised to 1. Okay, so it has unit this and it has dimension of this. Okay, similarly for magnetic intensity, state the formula. First you understand, yes, what was the formula for magnetization? Magnetization is the ratio of net magnetic dipole moment to volume of material. And I also explain you what conceptually what is the meaning of magnetization. Next we have magnetic intensity. Intensity. We'll study magnetic intensity first, then we'll see this formula, which is above, which is written above. Okay, yes. So what is the meaning of magnetic intensity? Magnetic intensity, it will be represented by H. It will be represented by H. It is the ratio of, it is the ratio of magnetic, yes, yeah, it will be the ratio of magnetic field to permittivity of free space. It is the ratio of magnetic field strength to permittivity of free space, or also known as a permittivity of vacuum. Okay, it is, what is magnetic intensity? It is H, and that H will be equal to, it is the ratio of, actually it is a ratio of B naught upon mu naught. That means magnetic field strength of free space to magnetic field strength of vacuum. How this formula comes into picture, I will explain you. Okay, the main formula is magnetic intensity is the ratio of magnetic field strength to permittivity of free space. Okay, so also we know that B naught, it is equal to mu naught into H. So this will be equal to mu naught N into I. What is mu naught? Permittivity of free space. What is N? What is N? Number of turns. What is I? I is known as the current. Okay, I is known as current. So in place of B naught, can we write mu naught Ni? Yes, we can write mu naught Ni. So this will be what? This will be equal to H is equal to, in place of B naught, I am writing mu naught Ni upon we have mu naught. this mu naught and mu naught will get cancelled, and you will get the HK value as n into I, where n is number of turns and I will be what? I will be your current. I will be your current. Okay, your I will be your current. Now, what is this n? N is number of turns per unit length. Turns per unit length. So current is in ampere and number of turns per unit length. Per unit length, na, that means what? It will be ampere per meter. It will be ampere per meter. Okay. So this is your magnetic intensity. Now, few more thing about the magnetic intensity, about how this formula comes into the picture. Yes. See, if you consider a solenoid on which wire are wounded, so what you will see that there will be two type of magnetic field. First will be external magnetic field, and second one will be produced by magnet. First inside the magnet, and second outside. That means in the free space. If we speak about the free space, it is written here. Yes, it is written here. Imagine a lengthy solenoid is carrying current I and has the n spins per unit length. It was demonstrated that magnetic field inside the solenoid will be provided by B naught is equal to mu naught into I. Yes, the field within the solenoid will be bigger than B naught if it is filled with substance that has non-zero magnetization. If you have a rod, let us consider this is your rod once more. Yes, in entire chapter you will see this only. You will have a rod on which wires are rounded, and because of this, that magnetic field is produced. Okay, so in the free space it was B naught is equal to mu naught H, and mu naught into H will be N into I, and inside it will be Bm is equal to mu naught M. Your B will be equal to what? What about the total field? Total field will be mu naught. Yes, sorry. Total field will be B naught plus Bm. Acha, what is B naught? Mu naught Ni. What is Bm? Mu naught M. So this will be equal to what? This will be equal to mu naught Ni plus M. And here it is B. So therefore, this, what is Ni? What is Ni? We have studied about Ni. Ni is nothing but your H plus what is M? M is your magnetization. So I will represent it by Mz. So this will be what? This will be B upon mu naught is equal to H plus Mz. So if you relate this, so you will get H is equal to B upon mu naught minus Mz. This is how this formula comes into the picture. You don't have derivation, you just have to remember the formula. I'm giving you a derivation also so that it will be easy for you people to understand the concept behind this. Okay, yes, once more. Okay, see what you have. You have a rod. In that rod there will be two magnetic field, inside and outside. Outside will be known as, yes, outside will be known as B naught, and that B naught is equal to what? It will be equal to mu naught H. And what about inside? Inside it will be known as Bm, and what is Bm? Bm will be equal to mu naught Mz. So your B will be equal to B naught plus Bm, so that means you will take mu naught H plus Mz. Yes, so therefore your next step will be B upon mu naught is equal to H plus Mz. What is Mz? Mz is B upon mu naught minus h. Okay, yes. So, or if you want, you can take the formula for h. Yes, this h will be what? H will be b upon mu naught, m will come here. One more thing. Yes. Next is, what is this symbol? This is Greek letter chi, chi. It looks like this. It's not a nasty symbol. Yeah, it is not like this. It is not this. It's like this. Okay, it's a Greek letter word, chi. That is your magnetic susceptibility. I repeat it once again. Yes, yes. Magnetic susceptibility. Repeat. Susceptibility. Susceptibility. Once more. Yes. It's susceptibility. Susceptibility. Yes. What is magnetic susceptibility? It is a ratio of magnetization to magnetic field intensity. Once more. Yes. What is your magnetic susceptibility? Your magnetic susceptibility is defined as the ratio of magnetization to magnetic field intensity. It is the ratio of magnetization to magnetic field intensity. So therefore, you can write your magnetization can be equal to magnetic susceptibility into H. Any problem? No? So this is your magnetic susceptibility. It explains the magnetic material reaction outside the field. It will explain you the relation, the reaction outside the field. This is your magnetic susceptibility. Okay, now how this formulas comes into the picture now. If we speak about the unit of the susceptibility, it will be it has no unit. Why? Because magnetization have unit ampere per meter, intensity have unit ampere per meter, so both will get cut. M upon h now. So it will be ampere per meter, it will be ampere per meter, it will get cut, and you will have no unit for this. Now, how this formula comes into the picture. If we see, we know that B is equal to B naught plus Bm. We have studied about this just previously. What is B naught? It is the magnetic field intensity of solenoid. It is magnetic field intensity inside the material. It is total magnetic field, or you can say net magnetic field. I repeat, net magnetic field of solenoid, magnetic field of material. If you see, this will be equal to what? This will be equal to mu naught H plus mu naught mz. You can write it as m also, but it is magnetization now, so I'm writing it as mz. So here it will be equal to mu naught H plus mu naught. What is mz? Mz is nothing but your susceptibility into H. We have something common. Yes, we have something common. We have mu naught. We have H. So here it will be what? It will be 1 plus susceptibility. Your B is equal to mu naught H 1 plus susceptibility. So your P will be equal to mu naught H 1 plus susceptibility. So therefore, and what is B? B is mu into H is equal to, this will be mu naught H 1 plus susceptibility. So H and H will get cancelled, and you will get mu is equal to mu naught 1 plus susceptibility. But mu is equal to mu naught into mu r, right? Compare. Yes, if you'll compare, there is mu, there is mu naught, there is mu r. What is mu r? Yes, your mu r will be equal to 1 plus susceptibility. That's the relation between them. That's the relation between them. And susceptibility can be zero, it can be positive, it can be negative. Okay, once more. Yes. about this formula, from where this formula comes into the picture from the thing B is equal to B naught plus Bm. What is B naught? What is B naught? What is B naught? What is B naught? B naught is mu naught. Yes, it is mu naught H plus, it is mu naught H plus mu naught Mz. You can take mu naught common outside. H plus, in place of Mz you can write chi H. This will be equal to mu naught H 1 plus chi. Mu naught H 1 plus chi. So this can be, what is B? Say what is B? This B is mu H is equal to mu naught H 1 plus chi. So your H and H will get cancelled and you will get mu is equal to mu naught 1 plus chi. But mu is equal to mu naught into mu r. Therefore, you will write mu r will be equal to 1 plus chi. Okay, so that was all about the magnetic susceptibility. Now, once again, we'll revise what things we have studied till now in this topic. In this topic, we have studied. The first thing was about the magnetization. What is magnetization? Yes, it is the ratio of net magnetic dipole moment to volume of material. And what about the magnetic field intensity H? It is the ratio of magnetic field in free space to permittivity of free space. Okay, then we studied about the susceptibility. It is the ratio of M and H. These three things we have studied from here. Explain you all this derivation. Let's see some questions related to it. First question, the relative permeability of medium is 500. What is magnetic susceptibility? Anyone? We have relative permeability. What is the meaning of magnetic susceptibility? We have relative permeability. What is relative permeability? Relative permeability is 500. What is the meaning of susceptibility? Yes. We have mu r. What is the value of mu r? 500. We have to find susceptibility. We know the relation that mu r is equal to 1 plus susceptibility, right? Yes, we studied about that. We studied that mu r will be equal to 1 plus susceptibility. So therefore, your susceptibility will be equal to mu r minus 1. What is mu r? 500 minus 1. So 500 minus 1 will be what? 499. So option D will be the right answer. Next. Which among the following is true about magnetic susceptibility? It is the ratio of magnetic intensity to intensity of magnetization. The SI unit of susceptibility is Tesla. It is the ratio of intensity of magnetization to magnetic intensity, or it is the ratio of magnetic moment to volume. this cannot be the right option. Why? Because Tesla is not the unit of magnetic susceptibility. Even magnetic moment to volume, it is the definition for magnetization. What about susceptibility? It is the ratio of magnetization to to magnetic intensity. So option C will be the right option, even not option A.